All right, there we go. We got our 2 axle plates made up and ready to move on to the next part. Hey, good morning, everybody. Welcome back. Saturday shop build day. So we're going to be back on the GS aluminum bobber build, and it's looking like we're going to be back on the milling machine today, making frame parts. Going to go ahead and make the rear axle blocks. They're going to be some rectangle tube aluminum, pretty simple part. Cut some slots in them where the axle will ride, and I don't know what else from there. Probably get those set up on the frame jig. Going to look at getting the motor mounts set up on the frame jig. Got to drill a couple holes. I don't know. We're just trying to work our way towards getting all the pieces made for the frame, so then we can look at making the frame. Possibly we'll work on the down tube. I mentioned briefly last week about having the piece of material radiused. So I've got that piece of material. It needs a lot of tune-up work. After being put through the slip roll, it really chews the aluminum up. So we got to get that all cleaned up and sanded. I think I'm going to drill that and slug it for like some speed holes. So lots of fabrication of aluminum parts today. So I hope you guys enjoy this. I hope the machine work's not too boring to watch. And that's it. We're going to get out there and make chips. All right, guys, so out here at the mill, we got our pieces of rectangle tube, 2.5 by 1.25 inches. And this is going to be the base for our axle adjusters. Going to get these set up on a couple parallels here in the vise. And then the first thing we're going to do is move this table over. And the first thing we're going to do is just get these ends cleaned up. This is obviously just a saw cut off of our chop saw. So we're going to get those nice and square. This first one is just an arbitrary length. The length doesn't really matter. I'll cut both ends of that clean. Then we'll take a measurement and match the other side. So real basic stuff here. See a nice square clean cut, and we're gonna flip it and do the other side. All right, perfect. These are both just shy of 12 inches, 11 inches, 990. So that is perfect for what we're working with. I'm going to go ahead and change this out, get a center finder in here. We got to find the center of our part and this edge, and then we can set up the slot. All right, so there's our midpoint on our Y. I'm going to just come over and find the edge of our X. Zero that out. And then we're going to come in 250, half the diameter of our edge finder. And then zero that again. And now we've got our dead edge of our part and our center. So we're ready to find our cutting tool. We're going to cut a 3/4 inch slot. It's a standard axle size on a lot of stuff. It's just the easiest thing. I can get good 3/4 inch material. We're going to make the axle anyway. I use on almost everything, so it just makes more sense. All right, so I'm using a 4 foot 5/8 end mill. Change this back over to high speed. And what I'm going to do is I'm going to come in 1.5 inches so that we have a nice shoulder at the back of the axle adjuster. You don't want it to be too close to the edge. I'll plunge that through, cut our slot, and then I'll move it over both ways to open up to 3/4. The reason I do it like that and not with a 3/4 inch end mill is when you cut on both sides of the cutter, one side always has a real trash finish. So in order to have a nice smooth finish on both sides of the axle plate, I'm going to do it in 3 steps. Takes a little bit longer, gives you a nicer product. And I really want the axle slot to be a little bit more than exactly 3/4. The adjuster blocks that go inside here will be dead nuts reamed to 3/4 for a nice perfect fit. But the slots on the axle adjuster plates, you want to have a little bit of play so you don't have binding when you're trying to adjust your axle. So if you're going to do this way, you need to make sure you have a center cutting end mill. Not all end mills center cut, and if you have a center cutting end mill, you can't really plunge it through. Just use a drill bit or something if you don't have a center cutting end mill to get your hole, and then you can go in there and do it like that. And I'm going to do the top and then the bottom instead of trying to hog it all out in one shot. And we're going to make a 3-inch long slot so we have plenty of adjustment. This end mill's loading up. I'm going to switch it out to a 2-flute. I wish I had a roughing end mill to do this, but I don't. So I'm going to swap this out. See if the 2-flute cuts better. That's 11/16. That's not what I want. Or is this 11/16 too? It sure is. All right. I guess we're using an 11/16 end mill because I don't read them, which is not a big deal. Still let us do our cleanups. So see if this works better. And I'm going to go with a 2.5-inch slot. It's looking plenty long. We got the top side cut. We'll go ahead and plunge it through the bottom. These are cheap end mills and they kind of suck. I need to get a coolant hooked up on this machine. I got all the stuff. I have more time to buy crap than I do to set it up, it seems. All right, we got our slot roughed in. We got an 11/16 end mill, which is 687, and we want the slot to be 750, so minus 0.75 is 625, and then we want to divide that by 2, which is 31 thousandths, so we're going to make 40 thousandths on each side. So go ahead and move our table over this way. 40. Put it back in. Sneak in here and measure our slot, which is 757. I'm happy with that. Gives us a good enough clearance. I'm going to take this, go back to our other side 40. Put that down through our bottom and repeat the process. All right, last thing we're going to do here, just take our little deburring tool, deburr this, get that cleaned up, knock these burrs off here. I got to find some good files too. I got all these old files, but I'd like one that's a little bit more aggressive. But there you go. One axle plate. We used to do this type of setup on our drag bikes. Then years later, I saw John Harmon, who was a chopper builder in the, I don't know, I think late 70s and 80s. Used to build what he called the Dominator frame, and he's more famous for the Harmon front end. Lots of those around here and there. And anyway, I just really like the style of the frame. It's kind of drag bike inspired for me, so that's how we always end up using them. So gonna swap our other part in. We got to put our edge finder back and repeat the process. All right, there we go. We got our 2 axle plates made up and ready to move on to the next part. All right, so this is our motor mount from last week that we made, and I talked about at the end of the video. I printed up just the 3D portion, which we're going to be able to use to lay out our bolt hole here. I'm still not 100% sure how I'm going to drill this. I think I'm going to do it on the drill press. What I'm going to do is we'll clamp this in place, and then we'll clamp it into the drill press and use it to locate our hole. And then we'll do the same thing on the other side. And it should give us a dead even location, if I can hold it in front of the camera for you guys. So that's our plan there. But right now we've got our motor mount that we made off camera. This is the duplicate side to this one that we made several weeks ago. So I've got this in the vise. We're going to edge find it, find our center, drill our hole, all that good shit for this, and then figure out this motor mount. And then we'll have all our motor mounts ready to set up in the frame fixture. We can set our axle plates and then possibly move on to figuring out the down tube, which I'll show you guys here in a minute. Like I said, it's pretty chewed up from the slip roll. It happens with the material, so we got to do a lot of finish work on that. Then decide if we're going to drill it and slug it with a bunch of round tube just for more of a decorative thing than anything, which I think we're going to do because I really want this bike to surpass the King Tut, which is by far the nicest bike I've ever built, in my opinion. And so I want this one to be better than that. So we got to go for all the details. I'm actually going to even get somebody to come in and weld this frame for me. Probably Frank from West Virginia. If not, if he's not able to come down and do it, I'll find somebody else. But I want this thing to be perfect. And I can weld aluminum. It's plenty strong, but I just, the decorative part of the welding has never been my strength, especially with aluminum, and all the time and effort and machine work and all that stuff. I'm going to get somebody who's a aluminum welding specialist to do it, just because I know where my strengths are, and aluminum welding is not something I'm top of my game at. It's fun to collaborate with people. Your stuff turns out way better that way, in my opinion, and I do what I'm good at, and I'll let somebody else do what they're good at, and we'll turn out a project that's top of the line. All right, so now we got our 2 motor mounts drilled and countersunk. This mount is going to get 2 bolts drilled angularly in this direction, if you can see what I'm talking about, like this, and bolt into the frame tube. But I haven't quite figured out how I'm going to do that yet, so I'm going to leave that. That'll make this mount removable so that we can get the motor in and out of the frame. This mount will be fixed to the frame. So that's why I made this one a little bit longer too. If you see how much longer it is, give us a little bit more meat, possibly even 3 bolts just depending on how it all goes. All right, so we're over here at the drill press. We've got our 3D printed template. This camera will focus. There we go. We got our 3D printed template. We got our 3/8 spotting drill, so we're just going to sit this on the edge of the table, get this lined up here, and go ahead and spot this side. Pop this off. See, we got our nice spot there. And we'll do the same thing on this other side. And I'm sure somebody's going to be all upset by this. I'm sure there's a better way to do this, but this is what I came up with, and I'm good with it. So, all right, we got both sides spotted. So I'm going to find a nice piece of square aluminum that we can use as a sacrificial deal underneath. I don't want to use wood because wood is not really very square, and I want to make sure that this hole is real perpendicular, you know, as much as possible. So I'm going to grab a drill bit, piece of aluminum, and we'll come back and drill these holes. There we have it, hole number one. I'll flip it around to the other side. Looking good. All right, so we're over at our frame jig. I'm going to go ahead and look at getting these mounts put on here. So we're just going to go hand tight with everything for now. Going to grab a couple bolts and nuts for the back mount. And there we go. We got our 3 billet motor mounts on. Got our axle adjuster blocks popped on there. Obviously, they're not tight. They're not set to the correct width or anything. But starting to get some pieces and parts looking like something. And now this is our backbone piece that I talked about. You can see how the slip roll really kind of just trashes the material. This will end up in this configuration. So we got a slight roll, but first things first, we got to get this piece of material, make sure I can even get it cleaned up to a satisfactory level that we can use it. So we're going to head over to the welding table, do some finish work, see if we can get that looking how we want. If we can, then we'll look at laying out some holes to drill for speed holes and such. Oh, yeah. All right, guys, so we got our piece. I'm going to start out with some 80 on a DA and just see how that does, if it gives us what we're looking for. All right, so this cleaned up really well. There's still some scratches and stuff in it, but a lot of that we're going to eliminate when we drill it. So I'm going to call that good for now. Then obviously once we drill it, weld it, it's going to be completely finished, and the last bits of that will get eliminated. But really happy with how that cleaned up. So we're going to head back over to the jig, try and get our steering stem angle marked, get this trimmed off. And then we'll trim off the bottom and figure out how to lay out our holes. All right, so just gonna lay this up here. Got our mark there. Gonna jump on the bandsaw, cut this off, and come back, check our fit. If it looks like we want, we will figure out how to cope it. Oh yeah. Loving that. So I think we can sit this upside down in the mill probably like this. I have to go over there and check and see if we can get clearance, and then we'll cope it. So I'm going to head back to the mill. All right, so we got our piece clamped in here. Used a little sacrificial piece to keep the jaws on the vise nice and square. We're going to find our center, and then we'll figure out what cutters we're going to use to cope this thing. Okay, so we have a 2-inch and then a 2 1/4 dimension. So I have an annular cutter that is 2-inch by 2 long. This is a little bit longer than 2 inches, so I'm not 100% sure how well this is going to go. What I think I'm going to do is I'll cut it all the way down as deep as it'll go, and then possibly we'll just have to finish it off by hand. I can't flip it because of the angle of the tubing, so I'm not 100% sure what's going to happen here, but let's see what we can figure out. All right, well, that is a beautiful thing there. So super happy with that. Now I just got to find something to cut in here, a little bit larger radius on the bottom. All right, so I got a hole saw. This would be probably my last choice, but it's what I have. We're going to just try and go nice and slow. All I got to do is just notch. I actually kicked the angle a little bit, so this will kind of notch the bottom and then go off. So like I said, not ideal, but I got it notched in there. I'm going to cut that off and I'm going to hand finish it. I don't want to go too far and screw up our 2-inch area. All right, so we got our cope. This is going to end up like this. Nice fit. We'll be able to weld everything, gusset it, all that cool stuff. Obviously, a piece of round tube is going to come out of here, come up and over. But my plan is to get the bottom part of the frame done. Then we're going to take these parts of the fixture off. We'll sit the motor in here, or just the empty motor, really. And then we can build the rest of the frame around that and the top motor mounts and all that stuff. So that's our plan. I guess next up we got to figure out how we're going to lay out these holes on this radius. All right, so we laid some Dykem out on this. This is an 1 1/4 material, or I'm sorry, it's 1 1/4 by 2 1/2. So we want to get a 1 1/4 scribe line on it. So this is an old tool I picked up at a garage sale with a whole bunch of old metalworking tools and tin snips and stuff. Somebody made a bunch of these, but it's real nice. Got a chunk of brass and a little tool steel point, if you can see it. Anyway, so I'll set this with a ruler to 1 1/4, lock that down, and then I could just scribe it along this radius, and it gives us the center point of our part. And you can confirm that by going to the other side and you get a nice scribe line. I'm not sure if that's showing up or not with the Dykem, but so then we're going to figure out how many holes we want to lay out. Now we're going to do an 1 1/2 hole. So, you know, we want to have a few holes, but we don't want to Swiss cheese it. So I'm thinking like maybe every 5 inches. So if we did that, we'd be like here, here. You know what I might do actually is draw this up on the computer. So that's 1 1/2 and 4 inches. I'm going to draw this up on the computer and lay it out, I think. Let us get a visualization on it, and then we'll come back and lay it out. All right, so we're just here in our Maverick CNC plasma software. This would be too problematic to cut on the plasma, but it's going to be handy to draw the layout. So I'm just going to draw up our piece, 2 1/2 inches by 24. And then I'm going to come in here and add the radius. So we'll go from here to here. Go in the middle. We're at 4. If I can get my hands to work this morning. I'm sure a lot of you guys have noticed my hands are extremely shaky most of the time. It's always been like that, but I notice it a lot more now that I watch myself on video a lot. Doctors don't seem to know what the hell it is, but it's super irritating.
Mind if I run over to that tire place real quick?
Nah, go ahead.
It's a big screw.
Yeah. Alright, so now we've got just about our radius. And we're going to figure out where we want to put our holes here. So start out. Okay, so we're going to go 1.5 inches, 1.5. And then we're going to come in here and try and pattern them. So we'll select this. And then we'll do this. And I'll try and find the arc. Point somewhere down here. Maybe. Nope. Okay, that's good. And then we'll just add in nah, it's too much of an arc. How do I, let's see, does this reduce it? Alright, let's try this a different way, because this is not doing what I thought. Let's go back to our straight. We'll just lay the circles out straight and get a count, and it shouldn't change anything for us visually anyway. Okay, so we'll just do this. Nope, this. Select the layout. We want to go 90 degrees. And then we want to figure out how much distance do we want in between each one. That gives us a 1/2 inch in between. That's about a 1/4 inch. All right, how many will that give us if we... So that's 9 holes. I wish somebody was here. Maybe let's look at 2.5. Because sometimes I like somebody else's opinion. I don't want to put them all the way to the bottom here because our lower frame rails are going to come in here somewhere. So that's 1, 2, 3, 4, 5, 6, 7, 8 holes. Every 2.5 inches on center. Or do we want to go, let's look at 3 inches. And get rid of 1. So that brings us down to like 21 inches. So we have 3 inches on the bottom. That should be plenty. I may end up, yeah, I think I like that. Yeah, I think that looks well spaced. Still plenty of meat in between each one. So that'll give us 1, 2, 3, 4, 5, 6, 7 holes every 3 inches. So I like that. We can lay out our scribes every 3 inches and then cut our holes. I don't know if I have an 1.5 inch annular cutter. If I don't, I'm probably going to hold off on... I'm going to go into this Amazon and see on my orders, because I usually buy them off of here. Let's see what I have. A 2 inch, 1 3/4, 1 inch, 1 inch. Damn it. Alright, so I don't have one. So I may leave that because these annular cutters cut so nice, and then I can use my annular countersink to do the weld prep. So I think what I'm going to do now is jump out on the lathe, We'll cut all our pieces of tubing, get those machined, weld prepped. We can lay them out on top of our actual tubing, get a look at them, and make sure that's what we want before we go cutting anything. And then I'm going to order a 1.5 inch annular cutter. I just really don't want to cut that with a hole saw. They suck, really. I mean, hole saws are good, cheap ways if you need to, cut one thing, but I've been buying these cutters as I need them for a job and just stacking them up. So, and we're going to jump out on the lathe and get machining. All right, so we are in my favorite place. I love working on the lathe. I hope one day I'm able to semi-retire, move my mill and my lathe into the garage, and just make parts here and there for people for my retirement job. That's my goal. So we'll see how it works. But got some 60-61 inch and a half 120 wall tubing. All right, guys, so here's all our tubing prepped. Head back to the welding table, lay this out, and see how we feel about it. All right, so got our pieces. Let's start laying these things out. Every 3 inches, we called it. So we'll go here. We'll go here. All right, so that's going to be our layout there. Looking at it from overhead, I think it looks pretty cool. Obviously, they're not precise, but I think that's going to work out well. All right, guys, so we're going to do today's build tally. So for this week, we had 3.5 hours of labor, so that's $490. Plus, I got a bunch of hardware in that we're going to use for the frame, some threaded inserts that we're going to use in the cases. Instead of through bolting it how I normally would, we're going to put threaded inserts into the cases and actually just bolt it all in. I thought it would make it a little bit stronger that way, being that it's an aluminum frame. Plus, I have a thought about using some special bolts that'll kind of disappear on the bike. So I got those in, 8 of those, $104. And then I had to get an insert tool for that, $31. Some miscellaneous hardware, $9. The shipping on all that stuff was $12. The round tube we used for our down tube slugs, $7. And the tubing we used for the axle plates, $20. So for this week, that gives us $673 and brings our total to $8868.72 so far on this build. So again, I'm going to keep doing this. If anyone cares, let me know if you care, so I know. I'm just curious if people ever give this kind of stuff any thought or not. So anyway, that's where we're at. So that's it. All right, guys, that's a wrap for today. It's got to be 110 degrees in that shop. I'm soaking wet like I was in a swimming pool, and I'm toast. So we're going to order that annular cutter, and we'll continue on with this next time. I hope you guys are enjoying it. I'm super, super pumped about this bike. I don't normally get too excited about many builds these days after almost 20 years of doing this, but this is something I've kind of had in my head for a really, really long time. So I'm starting to get excited for it, and hope you guys are too. So as always, appreciate you guys. Thanks for following along. Let us know what you think, And we hope to see you next time at Gattis Garage.